Okay, this video is about Newton's law of universal gravitation, or the force equation for how we calculate the force of gravity between two different objects. Remember, gravity is always a between thing. Even though we think about the gravity of the Earth, it's the gravity of the Earth between Earth and us. So two masses are needed. So, as a reminder from last class, masses in kilograms of the two objects. Many times these masses can be a planet. And then R is that distance between, I've got it right here, that distance between the centers, which can be really large for space and for planets. And then capital G is that number that is always there. It's always that number. That's a constant, just like pi. And F is the force. Force in newtons. As a reminder, it's always attractive. Gravity never pushes us away from Earth. It's always pulling us towards the center of Earth. So, before we use this equation, a couple reminders from the calculator. We want to make sure that capital G is saved, which we should have done in class yesterday, but if not, that's how you do it. You type in that G value, then you need to do store G. So again, I'll show you a little slower. You type in times 10 to the negative 11th. I just press enter to make sure it worked right. Then answer will automatically pop up if you hit this button down here, store, and then you go alpha G, which is tangent button. Now G is always saved, so we can type that, the letter, into our formula when we need to use it. A couple other tips. We're going to have big and small numbers, so be really careful as you type in things in scientific notation. We also need to use parentheses when those scientific notation things are included. Now, some calculators you actually don't, so you can kind of play around and see the settings on yours. And then here's just some other helpful things to know. So mass of the Earth, kilograms. Remember, radius, if Earth is a circle, radius is that distance there. It's not always the R in the equations, but we sometimes can use it as the R in the equations, depending. So this video is going to go through questions 1 through 7 in your problem set. Sometimes I'll just give you the answer and you will have to fill it out and try to get there on your own. And remember, if you need more help, the problem set key is on the overview page of Canvas. But for many of them, I'm going to walk through step by step how this goes. So what is the force of gravity? Solving for force between two people. So remember, any object with mass can have gravity. It doesn't just have to be a planet. Each with a mass of 75. So mass of one object is 75. Mass of the second object is also 75. That are standing 2 meters apart. Distance between their centers, 2 meters. Okay, so our formula, F equals big G. Oh my gosh. M1, M2 divided by R squared. Helps to write out the formula, especially as we're getting used to it, just to practice. F equals, remember big G is in our calculator, so we can just include that. 2 squared. Now, in the calculator, since we don't have scientific notation, we can type that in as it is written the same way without parentheses. So alpha G times 75 divided by, and if you want to, like I often will do an enter there, divided by 2 squared. Now you can see alpha G times, there's other ways to write this. I could do the 75 squared because there's 2 of them, and I don't need to press and enter. I could just do it in one step, same answer. So remember, when writing our answer, E negative 8 is the exponent. That matters. This force of gravity between 2 people is very, very small. Not even half a Newton, not even a quarter of a Newton, not even eighth of a Newton. Very, very small. So we need to include that as part of our final answer. So in writing our final answer, we don't need to include all the decimal places though. I generally will round to the second one. So I'm going to say 9.38 times 10 to the negative 8. We don't write it with that E like the calculator does, newtons. Final answer, very, very small. Number 2, what is the force of gravity between the moon and Earth? Answer in newtons gives us distance between the centers. Okay, so that is giving us R. And the moon has a mass of, so that's one of our m's. Okay, so we are solving for F. One of the m's is the mass of the moon. The second m is the mass of the Earth, which we can find in our notes. And the distance between their centers. Now, this is not necessarily the distance between them. Like if we were to fly from Earth to, if we were to fly from Earth to the moon, we wouldn't go this far. This includes those centers or radiuses of the planets. So we're going to plug these numbers into our equation. Now we need parentheses because we have scientific notation. So parenthesis. Parenthesis. Doesn't matter which mass is first. Now, since that radius is not in scientific notation, we don't need a parenthesis. 1, 2, 3. So get out your calculator and actually solve this one. Make sure you can type into your calculator this process to get the right answer. Otherwise, when you work on Quest, you're going to be really confused at how the right answer is received. So alpha G times parenthesis 22nd. Now notice my cursor's up here. I have to drop it down. So careful typing this one in. 3, 8, 4, 4, 1, 2, 3, 4, 5 zeros squared. Great. So that is the gravitational force between the moon and the Earth. If we notice how huge it is, we can see that this is going to cause the Earth to, the Earth, but also the moon to move. And so we want this whole answer, but again, I'm going to round and cut that off at the second decimal. So I'm going to write 1.98 times 10 to the 20th. If you type this in wrong without parentheses, oftentimes you'll get the right part of the answer at the beginning and just your exponent is off. Now a hint when you're typing this into Quest, this part of the answer, the times 10, you'll type in as E. So on Quest, you'll type it in how your calculator writes it. It's kind of the computerized version. Number 3, try setting it up on your own. Pause the video, try to set it up on your own. But notice there is going to be something tricky with the math algebra steps. So I'll silently work through it here, but try to set this one up on your own. So your setup should be like this. Both masses are the same here, but we're solving for R. So we need to, and this looks like a mess, multiply both sides by R. That will get our R out of the bottom. So if I multiply this side by R squared, they cancel out. Whatever I do on one side, I have to do on the other. So that's going to leave me with R squared times 5,000. Oops. And that's going to equal G times 5.5 times 10 to the 10th, 5.5 times 10 to the 10th. From this point, we then need to divide by 5,000 and then square root. So divide by 5,000, then square root. So I'll show you this in the calculator because I'm kind of running out of space on the iPad. But another way you could think about this, actually, before I show you in the calculator, if you like cross multiplying from math, or someone called it the butterfly method, I thought that was kind of nice. We can use that too. So if we cross multiply from math, R squared and 5,000 go together. And an imaginary 1 and the G mess go together. So that is just another way to write this. Now I'm going to write a squared there, meaning there's two of them multiplied together. So let's go to the calculator to see how we're going to get this here. So alpha G times 5.5 times 10 to the 10th. Now I'm going to do the squared method. It's a little easier and faster. So squared, enter. Now we have that equals 5,000 R squared. We have to divide both sides by 5,000, then square root. A hint to get this answer thing, if you need it in a square root where it's not automatic, the answer down here is blue. So you hit the blue second and then the minus sign or negative, and that'll put the answer from above. So 6,352 meters is our final answer. 6,352.44 meters. Four, 5, and 5 are conceptual. Think about yesterday and the simulation and think about what those would be. We'll check in on the whole group class next class. Now, number 6, we will check in on the whole group class about this one next class, but I want you guys to try to solve it, okay? So I'm just going to walk you through the basics, and then I think you can do it. So ultimately, we're solving for acceleration due to gravity. To get A, we need to use F net equals MA. A is our question mark, okay? However, we don't know the F, and right now we don't know the M. Now, if we keep reading, for an object with a mass of 100 kilograms. So that little mass right there for us is going to be 100. We're wondering how fast it's going to move, what its acceleration on the surface of Earth. Okay, so in order to solve for A, if we know M, we also need F net. to get F net here, I want you to use F equals G M1 M2 divided by R squared. Now, for these numbers, for the R and M2, use Earth numbers. Look in your notes, and it tells you in your gray notes what the radius of the Earth is and what the mass of the Earth is. Okay, your other mass here is going to be 100 because it's that object. And then G we know. So solve step 1. Solve for this force. Step 2, plug that force over here with this 100 and solve for A. I will check to see, you don't have to have the right answer, but I want to see that you tried on this one on our whole group class. In terms of number 7, we will solve together next class. You don't need to have this one. So the rest of your time right now is Quest, and you can do all of them. We only have one equation this unit. And there's 8 questions. A couple are kind of conceptual, so you have less tries on those. Be careful as you're working through.